Hi folks, welcome to the part 5 of the 6.1 videos. And so in this video, we're going to go over two examples of graph transformations with cosine. Okay, all right, let's get started. Take a look at example 4 here, all right? And if we look at example 4, we might think, oh, this looks a little bit different, okay? And it is in a few ways. And so it's really important that we take the time to rewrite it so that the form matches what we have when we look back at the graph transformations from the previous page. Okay, so we want to see the B, we want to see the C, we want to see the D. And if I think about what we do here, the first thing I want to do is write this so that the x comes first, right? So negative 2x plus pi over 2 minus 2. Okay, so when I compare this now, it looks a little bit better because I've got the x first and then the almost c value, right? But just like one of the examples for sine, we really have to remember to factor here, okay? If we don't factor, we're going to end up with the incorrect graph. So we get cosine. This time we're factoring out a negative 2, right? And we want x plus or minus something in there. And whatever that something is, that's going to be our c value, okay? So first things first, I notice that I'm actually factoring out a negative 2. So that means that instead of being a plus in here, it's actually going to be a minus, because when I distribute this back, like a negative times a negative is how I get that plus up here. Okay. Now our question is 2 times something gives us pi over 2. So we can almost say, all right, well, let's take pi over 2 and divide it by this 2. And when we do that, we'll end up with pi over 4. Okay. All right, looks like we've got our graph transformation. So let me just shrink this a little bit so that I can label right underneath which ones we're going to do for second and third. Okay, so first off, we've got a horizontal shift to the right. Second, we have a horizontal compression, and we have a reflection. And then last but not least, we have a vertical shift. Okay, so let's get started. Y equals cosine x is our parent function. So we don't want to start at 0, 0, but we're going to start at 0, 1 and go down and then come back up, and then go down and then come back up. And we'll take this, connect them, and then before we move on, mark our center point. Okay. All right, let's do our shift to the right. All right, so we're going to the right, pi over 4. That's y equals cosine of x minus pi over 4. And so if I think about this graph, every box, like the big ones, are pi over 2 or half pi. So if I want a quarter pi, it's actually exactly 1 box, okay? So I'm going to take every point I have and move it over 1 box. And I'm going to be really mindful to mark off my center point. Okay, I've just moved everything to the right, pi over 2. All right, so now we have that negative 2. That negative 2 does two things. It is a horizontal compression of 2, and there is a reflection over the center point. Okay, it's a reflection over the center. So that corresponds to y equals cosine of -2 parentheses x minus pi over 4. Right? And so that means that I'm going to take all my x values, I'm going to squeeze them in together around the center point, and then I'm going to flip it around the center point. That means my center point stays. Let's go ahead and mark it for us. But then this point and this point, they're going to squeeze in twice as close. So only one box away instead of 2 boxes away, right? Now these 2 points are 4 boxes away, and half of 4 is 2. So now they're going to be down here, right? And I just kind of keep continuing that pattern until I filled out the grid. And then I go ahead and connect everything. All right. And so I've done my squeeze and my reflection. Now it doesn't look like it's been reflected because cosine is even, right? So we flipped it around the center point. This point actually is this point, okay? So if we were to keep track of a few more colors, we might even say that this point is here and that this point went to here. Okay, so there is a reflection. It just doesn't seem so visible because cosine is even. All right. Now, last but not least, we got to shift everything down 2. So we're going to shift down 2 and get our whole equation there. And we're going to go ahead and take every single point and move it down 2 units. And then connect everything. And keep track of that center point. Okay, so let's zoom out for a moment, but we've got all of this on one page and we can see that progression. We've got our cosine, we slide it over, we squeeze it in and flip it, and then we move everything down too. Okay, all right, we've got one more example here. Take a look at that last example and see where we go. All right. All right. Ooh, I see a b value. That means that I do need to factor. I'm going to write a note to myself. I got to factor. And I've got negative cosine. Whoa, cosine of 1/2 x minus something. Okay. So I got to think about x, or sorry, 1/2 times something gives me pi. Or we can think about it, pi divided by 1/2. And when we divide by 1/2, it's actually the same as multiplying by 2. So we end up with 2 pi, all right? Now let me squeeze this in a little bit smaller and move that up so that we can label which one comes first, which one comes second, which one comes third. So our horizontal shift, we're not squeezing it in this time, but we're actually pulling things out twice as far, okay? And then we finish off with a vertical reflection. All right, let's get started. Y equals cosine x. All right, let's graph it. And, oops. And in case any of us are out there or maybe thinking in our brains, oh, I wish I didn't have to graph every single point. And I think the more we graph, the easier it is for our brains to sort of like remember where we want to put things, okay? All right, we are shifting to the right 2 pi. y equals cosine of x minus 2 pi. So the center point, this center point actually goes all the way out here now. So becomes there, okay? Now, that means that the right half of the graph is like off the page, but then this part is going to be right here, okay? So in fact, when we draw these, it might look like nothing has changed. Good thing we're keeping track of that center point, so we kind of can see it's actually a different point than the one we started with, okay? All right, now this 1/2. That is a horizontal stretch by 2. So y equals cosine of 1/2 x minus 2 pi. Now I got to stretch around the center point. So center point stays. But now I'm going to pull things out twice as far. So we're not squeezing in, but we're making them further apart, right? So that means that this point is not going to be 2 boxes away from the pink one. Now it's going to be 4 boxes away. And we keep stretching and stretching and stretching. And we actually end up with a really sort of long wave. Okay, one might even say that this has a wavelength of 4 pi instead of 2 pi. All right, last thing, this negative here means I gotta multiply all my y values by -1. So that's gonna give me the reflect over the x-axis, right? So y equals negative cosine 1/2 x minus 2 pi. And so that means my pink point is actually coming down here. The green one stays times -1 times -1 times -1, right? And so 0 times -1 gives me 0, which is why I don't have to change the green point. Alrighty, let's get this all on one page. And that, my friends, is our last example for graph transformations. And I hope that's been a good review of some things that we've been looking at throughout the summer session already. Alrighty, I'll see you later.